Okay, going through this 9.2 quick check. First thing is this paragraph. As you go across a period, the number of protons increases, so the outer electrons experience more attraction to the nucleus. Therefore, the atomic radius decreases and the ionization energy increases going across the table. So we're saying here that as you go across a periodic table, across a period, remember a period is each row of the periodic table. Okay, as you go down a family, so we're talking about this way. Okay, as you go down a family, the number of layers increases, so outer electrons are farther from the nucleus. Therefore, the atomic radius increases and the ionization energy decreases going down a family. So again, going across, you get more protons. Going down, you get more layers. That's important. Okay, the atomic size for each pair. Circle the one that's larger, then give a quick explanation. Okay, sodium and magnesium. Now the idea here is if we're looking at the periodic table, we're trying to pick out what is the relationship between these two. So if we say sodium and magnesium, they're right here, they're next to each other. Okay, so we're saying as you go across, there are more protons making it smaller. Okay, so circle each pair. Which one is larger? Okay, if the larger sodium is larger, because as you get across, you get more protons. Okay, greater attraction. And they get smaller as you go across. Okay, chlorine and bromine. Okay, chlorine and bromine. Now we're looking at two things way over here. Okay, so they're vertical. Okay, so the idea here, who's larger? Bromine is larger. Okay, why? Because it has more layers. Okay, sodium and sodium plus. Okay, now we're talking about the same element only with different numbers of electrons. They both have the same protons, but different numbers of electrons. So which one's larger? Okay, sodium is larger because it has more electrons. Okay, therefore more electron-electron repulsion. And that's going to make the cloud a little bit larger. When it becomes sodium plus, it loses an electron. So sodium has more electrons. It's going to do that. Okay, sulfur and sulfur minus, again, element and its ion. Okay, who's larger? Okay, the sulfur because it has more electrons. The ion in this case, because it gains electrons, so it has more repulsion. It's larger. Okay, F minus and neon. Now we're going to say, what are we talking about? We're talking F minus and neon. Okay, so those two are going to be both isoelectronic with neon. Okay, F minus has the same number of electrons as neon, so the same electrons, same number of electrons. Okay, who's got more protons? The more protons you have, the smaller you're going to be. The fewer protons you have, the larger you're going to be. So F minus only has 9 protons, where neon has 10. So F is not going to be as small. It's going to be larger, not as much attraction. So fewer protons, less attraction, larger atom. Okay, Ne and Na plus. Okay, now we're talking about Na plus and Ne. So they're next to each other. So again, they both have neon configuration. They both have the same electrons as neon. So again, the same number of electrons. So who has fewer protons? Neon has 10, sodium has 11. So neon is the larger one. F and AS. Now we look at that. Here's F. Okay, let's change color. Here's F. Okay, and arsenic is over here. So now, remember we talked about that there's a trend. They get larger this way and they get larger down. So this is both of those. So certainly the arsenic is going to be the larger atom here. Okay, and it's going to have both reasons. It has more layers. And it has fewer protons, okay, pulling in on those layers. So both of those are going to do it. Now we say fewer protons, we don't mean fewer total protons, fewer protons that the outer electrons can feel. Okay, and sodium and Na and Be, okay, same deal. Here we're talking about Be, here we're talking about Na. Okay, so again, they're the same situation. They're this upper left, lower right. So sodium is going to be the larger. Okay, same thing. It has more layers than beryllium does, and the outer electrons feel fewer of those protons. And that's that part of the question. Okay, then we have down here, what about ionization energy? Okay, for ionization energy, what I'm looking for, higher ionization energy, is the same thing as smaller size. Okay, same reasons for smaller size, because the smaller it is, the closer the electron is, the harder it is to remove it. So we're going to answer these, okay, same thing, higher ionization energy, smaller size. Na and Mg, who's smaller? Mg is smaller. Why? Because it has more protons. Okay, on the same layer, it's going to be more attracted in smaller, harder to pull off that electron. So that's why it's got a higher ionization energy. Chlorine and bromine, this time's chlorine, because it has fewer layers. So that electron you're trying to remove is closer to the nucleus. So same thing, smaller size matches up with higher ionization energy. F and As, okay, so here is S, here are these two again. So F and As. Okay, so the smaller one is going to be the one that has the higher ionization energy because it has fewer layers and more protons. And again, Na and Be, we saw that, that's these two over here. Okay, and Na and Ba, so again, the smaller one is going to be the one with the higher ionization energy. So the thinking and the thought process works with higher ionization energy, look for the smaller atom. And that's the quick check.